Imagine walking down a busy city street in the late 1800s and looking up toward the sky. You would not see the clear, open horizon we are used to today. Instead, you would see a dark and heavy canopy of copper wires. In cities like New York or London, thousands of individual lines stretched from rooftop to rooftop, sometimes so thick they blocked out the sun and whistled in the wind. This was the early reality of a world trying to figure out how to talk to itself. It was a period of incredible excitement, but also a time of massive technical frustration. Before we had the seamless digital networks that connect our pockets today, we had a physical, tangled mess that nearly brought the entire dream of instant communication to a halt. To understand how we fix this, we have to look at the problem that existed before the telephone even arrived. For decades, the telegraph was the king of communication. It was a miracle of its time, allowing a person to send a message across a continent in minutes rather than weeks. But the telegraph had a major human bottleneck. You could not just walk up to a machine and use it. You had to know a complex code, or you had to pay a specialist to translate your words into clicks and back again. It was a cold, indirect way of sharing information. People wanted something more personal. They wanted to hear a human voice. When the breakthrough finally happened in the mid-1870s, it felt like magic. For the first time, sound could be turned into electricity, sent down a wire, and turned back into sound on the other end. But there was a massive catch that no one really saw coming. In the very beginning, if you wanted to talk to someone, you had to have a physical wire running directly from your house to theirs. If a doctor wanted to be able to talk to 5 different patients, he needed 5 separate wires hanging off his roof. If a business wanted to talk to 20 different suppliers, they needed 20 different lines. It was a point-to-point system that worked fine when only a few people had the technology, but as soon as it became popular, it became a nightmare. This was the great failure of the early telephone era. The inventors had created a brilliant device, but they had not yet created a network. They were trying to build a world of conversation using the logic of the telegraph, where every line was a dedicated path. As more people signed up for this new service, the sky above cities became a literal web of hazards. During winter storms, the weight of ice would snap these thousands of wires, sending them crashing into the streets below. If a fire broke out, the tangled lines made it almost impossible for firemen to raise their ladders. The technology was a victim of its own success, trapped by a physical limitation that could not be solved by just adding more copper. The turning point came when people realized that the value of the telephone was not in the wire itself, but in the ability to connect to anyone at any time. The breakthrough was not a better piece of hardware, but a new way of organizing the system. This was the birth of the switching network. Instead of every house having a direct line to every other house, every house would have one single line that ran to a central hub. This hub, or exchange, would act like a giant traffic controller. When you picked up your phone, you weren't calling a person yet. You were calling a room full of people whose entire job was to listen to your request and then physically plug your wire into the wire of the person you wanted to reach. This change shifted the entire landscape of human connection. It turned a chaotic mess into a structured system. In those early days, the heart of this system was human. Most of the early operators were young boys, but they were often found to be too rowdy and impatient for the delicate work of managing hundreds of simultaneous calls. Soon, the industry shifted to hiring women, who became the indispensable backbone of the global communication web. These operators had to be fast, polite, and incredibly organized. They sat in front of massive walls called switchboards, which were covered in hundreds of little holes and dangling cords. It was a choreographed dance of hands and wires, connecting families, businesses, and emergency services in real time. As the system began to scale, the economics changed. The more people who joined the network, the more valuable the network became for everyone else. This is a concept we are very familiar with today, but back then it was a brand new lesson in how technology grows. It wasn't just about selling a product. It was about building an infrastructure. Standards had to be created so that a call from one city could eventually reach a call in another. Engineers had to figure out how to keep a voice signal from fading away as it traveled over hundreds of miles of wire. They invented amplifiers and better insulation. But the biggest challenge remained: the sheer volume of connections. By the turn of the century, the manual switchboards started to hit its own limits. As cities grew, the number of operators needed to handle the traffic became unsustainable. If the system had stayed manual, some estimated that every single person in the country would eventually have to be a telephone operator just to keep up with the demand. This led to the next great leap, which was automated switching. Instead of a person hearing your voice and moving a plug, a series of mechanical pulses would tell a machine at the central office which connection to make. This was the ancestor of the modern computer. These massive mechanical rooms would click and whir as they routed thousands of calls without a single human hand touching a wire. The ripple effects of this advancement were felt everywhere. The way people did business changed. You no longer had to live next door to your office or your customers. The world started to shrink. News traveled faster, and the social fabric of the world became more tightly knit. But there were also losers in this race. Small companies that could not afford to build these massive exchanges were swallowed up by larger ones. The industry moved toward a monopoly model, because having one single unified network was much more efficient than having 10 different companies that could not talk to each other. We traded competition for the convenience of a universal system. Why does this story still matter to us today? Because we are living in the direct legacy of those early copper wires. When you use your smartphone to send a photo or join a video call, you are still using a switching network. The only difference is that the switches are now made of silicon, and the signals move at the speed of light through fiber optic cables or through the air via radio waves. The lesson of the early telephone failure is that the most important part of any technology is how it scales. A great invention that cannot be shared or connected is just a toy. A great invention that builds a network becomes a civilization-changing force. We often think of progress as a straight line of better and better gadgets. But the story of the telephone shows us that progress is often about solving the mess that our own inventions create. We moved from a sky full of dangerous wires to a hidden global system of automated hubs that allow for the instant exchange of human thought. It was a transition from the physical to the systemic, and it set the stage for every digital advancement that followed. And that is how the telephone and its switching networks transformed from a tangled failure into the foundation of our modern connected world. In the next episode, we will move forward to 1897 to see how the next breakthrough in the timeline changed the stakes of efficiency once again. We will explore the diesel engine and see how a new way of harnessing power allowed industry to scale to heights never before imagined. If you enjoyed this journey through technical history, consider following the series as we continue to explore the ideas that built the world.